We're going to look at the third form of a linear equation. We've talked about standard form, slope-intercept form. Let's get everything, like earbuds away, fellas. Let's get those gone. Click them closed, etc. We're going to look at the third form, other than standard and slope-intercept, which is point-slope form. Why do we have so many? Well, each of them has their own purpose, right? We'll use standard form when we solve big linear systems. This is something that you do in physics and in engineering. You do this all the time. You're solving big linear systems using matrix methods, and then you definitely want to write out all the equations in standard form. That's part of that process. So there's one application of that. Why slope-intercept form? Because it's so easy to graph, right? If you write an equation in slope-intercept form, it's the simplest form to graph from. And point-slope form is really not a form that we usually leave the line in. It's kind of a starting place. What are the ingredients of point-slope form? Well, a point and a slope. That's it, right? We're going to input a point and a slope, and we're going to into this form, and then by doing a little algebra, we can easily put this into one of the other two forms, standard form or slope-intercept form. Okay, so let's do a little quick review. What's slope defined as? Like you talk about, just slope of a line. What is that? Rise over run, isn't it? Yeah. So it's rise over run. A lot of times we'll call that in math, especially like when we get into calculus, we'll use this terminology a lot. We'll call that delta y over delta x, where delta is a symbol in math that just means change in. So this would be the change in y over the change in x. Isn't that really what rise over run is, though? Right? Hey, Peyton, why don't you close that up? So if I go from one point to another point, the rise is going to be how much the y's change, and the run is going to be how much the x coordinates change, right? So that's a good mathematical way of saying rise over run. And then if we want to get a little bit more specific, we can say something like that. Now, a lot of times we talk about slope as being, we'll write it a little bit differently. A lot of times we'll say slope equals, you've probably seen this, right? Y sub 2 over Y sub 1 minus X sub 2 minus X sub 1. Okay, what's the meaning of those subscripts? We talked about this a little bit. What does that mean when you put a subscript like that next to a variable? How is that different than just saying Y and X if I have a sub 2 or a sub 1?
Like two different Y variables.
Okay, two different, and yeah, variables, yes. I mean, it's a variable. But these are getting more specific. You're right. You're on the right track. Whenever we put a subscript next to a variable, we're talking about a specific instance of that variable, a specific example of that variable. So when we use a slope formula like this is how we calculate a slope from 2 points where we know the coordinates, right? Point number 1 would have coordinates x1, y1. Those are numbers that we know, okay? Point 2 would have coordinates x2, y2, and we would just plug those 4 numbers into that formula and calculate a slope. And you've done that many, many times. Okay, we're going to do something slightly different here. Okay, we're going to do something where we're going to have a line and we're going to have 2 points, and we want to calculate a slope. But only one of those is going to be a fixed point, is going to be a point where we know the coordinates. The other one is going to be this variable point that can slide along the line, okay? Make sense? So this one, we're not going to call it x2, y2 because it can change, right? As it changes, does the slope of the line change? It doesn't, right? Because the slope of the line is a property of the line that's always the same, isn't it, right? Okay, so then if we want to use this fixed point, which is a point whose coordinates I know, and this is kind of going to go with our line, with our formula that we're using today, isn't it? We want to be able to input a point. Well, that means we must know the coordinates of at least one point, and we're going to input a slope. How do we calculate the slope? Well, we can calculate the slope from a slope triangle. Okay, so we're going to do rise, which is that distance. What is that distance right there, that vertical distance, everybody? So like if I were to take this point has a y coordinate of y, right? This point has a y coordinate of y1. So what's the distance between those two? Y minus y1. Okay, so y minus y1 is my rise. That's delta y. What about my run? Well, my run is going to go from this x value, which is x1, up to this x value, which is the variable x. How far apart are those? X minus x1, right? Give me thumbs on that. Does that make sense? Okay. Okay, so then look what we get. We get our slope formula just looks like that, rise over run, y minus y1 over x minus x1. Okay, so now what if we just do a little algebra here? What if we clear the fractions? How would I clear the fractions here? Multiply both sides by what? Good, yeah, x minus x1, right? That makes sense? Or I could just cross multiply if you want. I mean, however you want to think about that. We're going to write this, we're going to get rid of the fractional nature of this thing. Okay, so what's that means if we multiply both sides by the quantity x minus x1, that's going to cancel the denominator on the left side. I get something like this. What would my next step be if I want to kind of simplify this? Well, for one thing, I guess I could leave it like that, couldn't I? Right? Eventually, if we wanted to put this in slope-intercept form, I would have to do a little additional algebra, right? I would have to isolate the y. I'm going to distribute whatever that number is for m and add the y1, which is a number, to the other side. But we'll get there. I'm going to stop here because this is our new formula that we're going to use. This is the point slope form of a line. Does everybody see why we might call that point slope? How many points? We're inputting coordinates from how many points into this? 2? Are you sure?
It's one and the slope.
Okay, we got 1 point, x1, y1, and a slope. Make sense? So that's the stuff we're inputting. Here are the variables that are staying the same. Right? Those are my variables. What are the numbers I'm inputting? Okay. The values I'm inputting are the coordinates of a point and a slope. Okay. And those go where? They go there, there, and there. Okay. So this is a convenient way for us to build a line because all we have to do is input those two ingredients, a point and a slope. Okay, let's try this. So simple one. How about this first one? Okay, here's my point slope form, right? What are the values I'm inputting in example one? What goes where? Where's the -1 go? Okay, that's x1, isn't it, right? That's the x coordinate of the point that I know. Okay, so this is x1. Where's the 7 go? Yeah, y1. And obviously m, that's pretty straightforward, right? So don't we just get something like that? Y minus 7 equals -4 times the quantity x minus -1, which is just x plus 1, right? And that is my line in point slope form. Now, a lot of times when you get into more advanced classes, ironically, people are a little less picky about how you write things. Like in calculus, I mean, I wouldn't care if I don't want them to have to hassle with putting this line into slope-intercept form. We don't care about that stuff. So I would just let them leave it like that. On the AP calculus test, students can just leave it like that. They don't have to change the form. But for now, we're going to. So what would the steps be to simplify that and put it into slope-intercept form? Distribute -4. Good. And then add 7. And we got it. Okay. How familiar are you with this point slope form? Have you guys talked about this before? A little bit? Okay, give me 1 to 5 on point slope. Okay. Oh, okay, pretty good. All right. So maybe I'm probably like spending a little too much time on this. Okay, next step would be what if we're not given something quite so basic? And this last one, I mean, my goodness, this was just plug and chug. They just gave me these two values. I plugged into a formula and I'm done. No big deal. Okay, this is a step more difficult. Now they're giving us just 2 points. Okay, how am I going to take 2 points and turn that into the ingredients for point slope? What am I going to do? Okay, I got to calculate the slope from the 2 points and then use which one of the points to plug in coordinates. Which one should I use, or does it matter? Doesn't matter, right? Whichever one seems most convenient, use that one. Like if I had one point that had great big numbers and one point that had maybe like zeros in it, if you ever have coordinates with zeros, plug those in because those are easy, right? Pick the one that looks the easiest. So we would just calculate a slope here. And so let's talk about calculating a slope for a second. This is so basic, but there are some simple mistakes that people still sometimes make. How would I calculate the slope of those 2 points? What could I do? Okay, so tell me what to write. You guys tell me what to write in my fraction that I'm using to create slope. What could I do? Okay, so I could do 8 minus negative 2 over negative 6 minus negative 2. Okay, would this work if I did this? Okay, what did I do wrong there? They're out of sequence, right? I can't do that. I have to be consistent. If I'm subtracting left points from right points, I have to do the same thing on the top and the bottom. It doesn't matter which order you go in, honestly. What's the other thing I could do here and get the same answer? Yeah, I could subtract right coordinates from left coordinates. I'm going to get the same answer, but I have to be consistent. So I could go negative 2 minus 8 over negative 2 minus negative 6. I'm going to get the same answer, aren't I? Okay, just whichever one seems easier. How do you know which one to do? Well, there's no like really, you can do either one. There's very little difference. I personally would always, if I'm going to do these things, I would just choose to subtract so that I get a positive number on the bottom of the fraction. That's what I would choose. So I would personally choose that way, but it makes no difference. Okay. How do you know how you're going to get a positive number on the bottom? You're going to get a positive number on the bottom if you're subtracting a left point from a right point, right? So you'd look at the x coordinates, negative 2 and negative 6, right? So which one is further to the right? Negative 2 is, isn't it? Does that make sense? So I would choose to do negative 2 minus negative 6. So I get a positive number on the bottom. But again, you don't even need to worry about that really. I mean, it just is a small issue. I find it just a little bit helpful, but take it or leave it. So then we calculate our slope, and when we do that math, it looks like we get negative 5 halves. So then now I'm just going to plug and chug, right? I'm going to plug negative 5 halves in for m, and I would probably use, which one would you guys pick? Yeah, the one with twos or smaller numbers. I think they did the other one for some reason. I don't know why. That's kind of dumb, but either way, they plugged in the 8 and the negative 6, and then just distribute and add 8, and you're done. Okay, give me thumbs. We all good on this stuff? Okay. All right. Okay. Why did I pick this one? Let me just think about this for a second. 3. I don't know. I guess because it had some fractions in it, but I don't even think that's that big a deal. You guys can do that stuff. Okay, let's do this one though. Let's do this one. Let me take one more look at that. No, we're good. We can skip that one. Okay, what about this one? First step. Find a slope. Okay. You guys tell me what to write. What minus what? It doesn't really matter that much. Just be consistent. We don't need to worry that much about making the bottom positive. What's one way to do this? Deacon, what's one way to do this? Okay, over. Okay. Okay, yeah, look what's going to happen. So on the top, I get what? 0. On the bottom, I'm not going to get 0, am I? Everybody agree? So 0 divided by a number, I don't even have to be more specific than that. 0 divided by a non-zero number is equal to what? Okay, good. What's 0 divided by 0? You can't do it, can you? Because you can't divide by 0, right? 0 divided by 0 is not doable. Okay, you can never divide by 0. Even 0 divided by 0 doesn't work. Okay, so we get 0 for our slope. Take your pick of a point.
Now, at this time, can I have sophomores, last name P through Z? If you need picture retakes, go to the Commons. Sophomores, last name starting with P through Z to the Commons, please.
Okay, so what am I going to plug in then? What could I do here? Which point probably be easier? Slightly. The second one maybe. So you guys tell me what values to plug in then. Y minus what? -3. So I'll make that y minus makes that a plus. What's my slope? We said was 0, right? So it doesn't matter. Very good. We don't even need to worry about that. 0 times anything is what? 0 every time, right? So the right side is equal to 0. So I get the equation y equals what? -3. What kind of graph is that? Show me with your arm. What kind of graph is that? Is that going to be this way or this way? It's going to be this way, right? And a quick way to remember that is if it's named by its y value, that means that all the y values are the same. Okay, so one thing it's also giving you then is the y-intercept. Everybody get that? So it's going through the y-axis at -3, and we know that if it's going through the y-axis, it has to be horizontal. Okay, so there's our answer on that one. Give me thumbs. Is that all good? Okay, okay. And the weird thing about it was just that 0 slope, but that actually makes things simpler, right? Okay, how about this guy? Let's calculate a slope. What minus what over what minus what? What do you think? Adam, help us out here. Over. Okay, now that's giving us a number on the top, right? That's not, when I say number, I guess I mean a non-zero number divided by 0. What's that? Undefined, yeah. Undefined. Okay, so if it's undefined, we really can't even do point slope form on this, right? If we try to do point slope form, things are going to blow up. Y minus y1 equals m times x minus x1. Well, how am I going to do that? How am I going to plug undefined in there? It doesn't work, right? Undefined is sort of like putting an infinity in there, and you can't do math like that. So we have to just kind of finesse our way out of this, think our way out of this. Well, what do we associate an undefined slope with? What kind of line? Vertical line. Okay, so then really what this is, we could rephrase this question in our head. We don't have to write this down, but really all we're trying to do is write a vertical line through, take your pick, how about 2,5? And we've done problems like this already, haven't we, on the assignments? How would you write a vertical line through that point? X equals 2, right? Because vertical lines are named by the x coordinate. So we get x equals 2. Okay? So there's an example where you can't technically really use point slope formula, but you don't need to because you end up with something that you can reason through in a different way. Okay, give me thumbs on that one. Okay. Okay, so then what about something like this? There's a lot of moving parts on this one. Let's think about this one. write an equation in slope-intercept form for the line that passes through the blue point, 6, 4, parallel to the line that passes through the points negative 9, 8 and 9, negative 4. So do you have any ideas how we could approach this one? Okay, let's find the slope of the red stuff first of all. Okay, good idea. If we find the slope of the red, what do we get? So let's calculate that. The slope of the red is what? What do you think? Dylan, helps out.
Negative 4 minus 8.
Over?
9 minus, well, plus 9.
Okay, good. 9 minus negative 9, so 9 plus 9. So that gives us what? Negative 12 over 18. So what's our slope?
Negative 2 over 3.
Good. Negative 2/3. Okay, so we got a slope. We've got, so keep going. What do I do from there? Say it again. I heard something. Good.
Just plug it into the equation
With 6, 4. Okay, so 6, 4 is our point. Now, how do we know that negative 2/3 is our slope? Because it's parallel. Okay, everybody see that? So these two lines are the red points on our line. On we'll call them the red line and the blue line, right? There's a blue line going through the point 6, 4, and that's the one we're trying to find, right? The red line, is that the same line? Separate line that goes through these points. Okay, so if I calculate the slope of the red line, because the two are parallel, that's the key word there, right? Because they're parallel, they have equal slopes, and so the slope of the red line is the same as the slope of the blue line. Everybody get that? So we could just use point slope with those values, and what do we get then? So we get y minus 4 equals negative 2/3 times what? X minus 6. And again, how do we get that? Y minus the y coordinate of our point equals m times the quantity x minus the x coordinate. Okay. If we distribute the negative 2/3, what do we get there? Negative 2/3 x. What's negative 2/3 times negative 6? Plus 4. So I'm going to add another 4 to this side. Everybody agree, and I get y equals negative 2. That looks terrible, doesn't it? Negative 2/3 x plus 8 is our line. Okay, let's see how we did. Okay, well, that ought to work, shouldn't it? Like, there's our red line, there's our blue line. If my slope is negative 2/3, that's going to be parallel to this guy. That takes us through the y-axis at 8. And, whoops. Yeah, those are parallel, aren't they? Okay. All right, one more. Well, maybe more than one more, I guess. Got a couple applications too. So there's our picture that we just drew. Okay, what about this one? We need a point and a slope, right? Okay, what's our point that we can use? 12, negative 4. Okay, we'll call that again. That's going to be our blue line. That's the one, that's our line. So there's x1, y1. What's our slope? What is it? 1/2. How'd you get that? Ah, okay, good. I heard a perpendicular. Yes, so if we're perpendicular to the red line, whose slope is negative 2, that's our weird symbol for perpendicular, by the way. It just looks like an upside down capital T. So m perpendicular would equal positive 1/2. That's the slope that we want, and there we go. Y minus negative 4 equals 1/2 times the quantity x minus 12, and you guys can take it from there, right? That's our equation in point slope form. Okay. Give me thumbs. How we doing? Okay. All right. So just quick, I just threw this in the notes for your benefit, just so you've got it. Here's everything we've talked about with linear equations. Remember, standard form. Okay, I want to just point one thing out about standard form. I mentioned this, but again, standard form is really not as restrictive as maybe this book makes it out to be. For now, we're going to be restrictive. Later on, we'll relax that. So standard form is ax plus by equals c, where a, b, and c are integers. The greatest common factor, this is important, the greatest common factor of a, b, and c is 1. And ideally, we'd like a to be positive. Okay, but does it have to be? Well, maybe not. And then quick review, parallel and perpendicular lines. You guys know this. Parallel lines have equal slopes. Perpendicular lines have opposite reciprocal slopes. Okay, and here's where, we're out here in like a minute, aren't we? Okay, so we'll hit these couple tomorrow, and then I'll give you a little chance to maybe work on this stuff in class.